Welcome to this course on climate finance. The course has a website. I'm going to start with that. This is a website that I will use to communicate with you and share information, documentation, and all of that. I assume you can see that here. This course it may be password protected. I'm not sure. If it's password protected, you just need to register right there on the website, put your email address, and then create a password, and then you can log in. I prefer I like to make my courses available to humans, but not to robots. I don't want my courses, especially the ones I have with sensitive material, to show up on a search engine, for example. So sometimes I protect my courses with a password. You just generate a password and then you can go in. When you go into this course, you will see this. You will see some lecture notes, 4 of them. These are old. I have brand new lecture notes that I'm finishing as we speak. This course is changing. The topic is changing very rapidly, so I need to make my notes to be very up to date. There's new regulation that is being passed almost every day, and so I like to keep my notes updated. This will still be there. You can download them today, but tonight you will have the ones that I will use now, so you can download those just after my talk. Then I have some web resources which are either important resources for you to follow the course and do the assignments that I give you and this and that, but also websites that will satisfy your curiosity on a number of topics. Okay, there's a lot of them on different issues. Then I have some video resources from YouTube that you may enjoy. I may augment this as a function of different things. Like I said, there are things happening almost every day. Sometimes these videos go offline, they become unavailable, like this one. I have some articles on climate risk that you may find interesting. Typically, every source that I have used for the course is here. The book has no textbook. There's really no textbooks on this topic. But instead of that, I have some papers, a lot of papers, manuals, statements, and this and that. The book bibliography is not very relevant. That's the course material. That's the course website. There will be assignments that I will probably be listing here. And this will be there to help you. Okay. There's a course description that either you have received or if not, I will send it to you by email. In this course, you need to do an assignment. You need to do a project. I will discuss that throughout today, which will count towards your mark. However, my expectation is that you take an active interest in the subject matter and that we engage in a lot of discussions about this while we are here. Okay, I feel tempted to say that participation should count for half the mark or something like that. Sadly, today I have to do this meeting online. I'm in Germany. I was supposed to be in Geneva tomorrow talking to the United Nations precisely on this topic. But I will be in Toronto next week. Next week, the course will be in person. The week after may be again online. I will do my best to meet in person, but we may have to have this course taught online many days. I'm going to start with with my presentations, with my notes. I'm going to. Are there any questions? No. Okay. I have some videos, so I want to share the sound. There you go. I assume you can see my screen now. Okay, so I'm going to talk about climate risk management. Today is an introductory talk. I should mention that I believe we have some students who are not from MMF taking this course. I believe that, which is great. Welcome to this course. There are two acronyms which appear in the financial sector: SDG and ESG. These are going to be acronyms that are going to be recursive. We're going to be talking about them over and over again. But I want to start by, as I like to start, which is telling you why you're here. Why do we have this course at MMF? I have here a statement by Mark Carney. Mark Carney is a very interesting person. He is the only person that exists who has been the governor of two central banks in different countries. He was the governor of the Bank of Canada from 2008 to 2013, and he was the governor of the Bank of England from 2013 until 2020. Currently, he's the special envoy to the United Nations for climate action and finance. He knows what the banking sector is. He knows what finance is all about. And he had this thing to say about climate finance. He said, climate change is setting in train a vicious cycle in which rising sea levels and more extreme weather are damaging property, forcing migration, impairing assets, and reducing the productivity of work. So he said this in the year 2021. And when someone like Mark Carney says this, we need to respond. We need to do something about that. I am convinced that a vast majority of you in your professional path, you will be faced with issues that have to do with this, with climate, understood broadly. I will talk about sustainability at some point later on. So this will be important for you to have some basis for that. In addition to what Mark Carney is saying, I also want to mention some other things that may be closer to home. This is what Barbara Svan said. She's the president and CEO of the University Pension Plan Ontario. One of you is scheduled to do an internship there. Okay, on average, one person does an internship there. So she said, our financial systems can and must play a critical role in financing Canada's transition to a climate resilient net zero future. She's very outspoken on these issues of climate. She manages a pension which is not very large, it's about $12 billion, not very large, but she's very active, and there's a chance that actually, to a certain extent, a lot of the Canadian pension plan sector is following her leadership on that. Now, perhaps more certainly representing a bigger organization is Jamie Dimon. Jamie Dimon, he's the chairman and CEO of JP Morgan. He said, immediately actionable opportunities, he was referring to climate goals, I'm paraphrasing, might require more financing, not less. Okay, so as you can see, he's focusing on his business, banking business, and he says these are going to require financing. So the bank is just has to be there. And the president and CEO of CIBC, Victor Dodik, he said banks and our clients focus on commercially viable solutions. The economics of change and sustainability need to work, which they do when they are constructed in the right way. If you read between the lines, all three are making very similar statements. They are talking about the need for the financial sector to be there. They are very careful to express what they say from a financial perspective. They are representing their companies. They are not representing themselves nor what they think. And their statements are very much in line with that. And in line with that also, I must say that this course is a course in mathematical finance. It's not a course in environmental science. I will use facts from environmental science here and there, especially today, but it is not a course on environmental science. It's a course in quantitative finance. Very important. And that's the approach I am going to take. There are wonderful courses on environmental science, and there will be even more courses. In fact, who knows, maybe one day I would love to teach a course on environmental finance, on environmental science about climate, but not this time. This is a course on finance, and I'm going to focus on the financial aspects of this, which involves investing, which involves credit risk, which involves risk management, and certain other topics. And I will try to adopt a very modern perspective on this, where we make a lot of use of AI. In fact, I'm going to try to highlight for all of you the role of AI in this, because I am sure none of these goals that Jamie Dimon is talking to are going to be achievable without AI. And that's a very interesting path for a new type of fintech to be developed. And that's why I want all of you to be aware of this. Okay, this will help you to stay competitive. Another reason this course is here, and this I'm not going to quote, I'm not going to put it in writing, but as far as I know, we may be the only program in mathematical finance that has a course like this. This gives you a competitive advantage when it comes to getting certain jobs that some other programs don't have. Let me go to the roots of what caused all of this. It all started around the year 1997. Footnote, I came to Toronto in 1992. So this is around the time I came to Toronto. In fact, one of the first lectures I heard myself in Toronto at the Fields Institute in their Wednesday seminars, one of the first lectures I heard was about climate finance, climate risk management. It was around the time that Kyoto had not happened yet, was about to happen. And what was discussed at the Fields Institute seminar is the need for a market that deals with emissions, a way for countries like, for example, Brazil, to have some compensation for the fact that they were reducing emissions. We cannot expect countries like Brazil to continue to do that for free. And this was discussed in Kyoto in 1997, and the result of that was the creation of an economic incentive to reduce emissions, something that has become carbon credits that I will discuss today. That started in 1997, and it started as an attempt to provide an economic incentive to participants, nations, companies, to reduce emissions. A few years after that, in the Paris Agreement of 2015, which was ratified by all countries on Earth except six. Only six countries did not ratify it. I have here either the ratification or the signed participation in the accord around the world. You can see you need a very fine microscope to detect the countries that did not participate. And there, what was said is best summarized with Article 21C. Article 21C is the most important article for you. Article 21C says, in the context of the accord, that one of the objectives is to make finance flows consistent with a pathway towards low greenhouse gas emissions and climate resilient development. So if 193 countries say that this is important, you have to believe it. If Mark Carney says it's important, you have to believe it. And if Jamie Dimon, Barbara Svan, and Victor Dodig said that this is something that catches their attention, and they're gonna devote their business attention to the issue, you gotta believe it. You gotta be there, because this is gonna be where you're gonna be. The size of the ESG markets, ESG is something I will talk about today, is related to climate risk, although it's not the same. The size of ESG markets, E stands for environment, as I think you all know, grows at a rate of about $1 trillion per year. A lot of that are bond issuances, of which green bonds are the lion's share. We will talk about green bonds later, maybe in a week or probably in 2 weeks. And these went up more during COVID-19. The speed of change actually grew substantially during 2020. So $1 trillion a year is a lot of money. It's a lot of money. The financial sector is going to be there. And in fact, as you have heard, Article 2.1c of the Paris Accord means that the banks are going to be there. That means that this money will hit you professionally at some point. And for that reason, at MMF, we decided that this course has to be there. You need to know about these things. I have some graphs here that may be hard to read on the screen. They'll be easier to read when you have them downloaded on your computer, but all three point to the same growth rate that I'm talking about. And if you talk about the actual size, the estimated size of asset under management of all of the ESG funds today in 2024 is around $30 trillion. This is about the size of the United States economy. And that's a mix of retail and institutional. So this is something which, like I said, cannot be ignored. This is the business that many of you are going to be in, either as direct participants, as counterparties, as consultants, who knows? But there's just no way that this money is going to be avoiding you. And the considerations are different enough from the rest of the courses we have at MMF that this course has to be here. What I have here in front of you is the latest ruling is of this year, 2024, from March. The Securities and Exchange Commission is adopting rules to enhance and standardize, essentially, carbon credit trading. So the carbon market is something that the SEC has declared to be a derivative. And because of that, we expect their trading volumes to go further up. Now, I don't know if this is something that has been mentioned to you, but let me have a quick question. Maybe we can create a poll here. See if we can do this. Okay, question one. Well, I'll ask you the question later. Do you know when derivative markets existed, when they were introduced, when they were created, and why? Do you know? Anybody wants to say? Maybe write in the chat. I'll tell you. Derivatives markets were created in the 80s. And the first such derivative was a swap. A swap is not a derivative. Many of you will say it's not a derivative. Well, back in the 80s, it was considered to be a derivative. And the big thing about swaps is that they were standardized. Today, even today, swaps are still ISDA contracts. ISDA is as ISDA, International Standards Derivatives Association, or something like that. This means that they've been standardized, they are standard contracts. That means that people can trade them. To do a swap will be very complicated. We're going to see swaps today. To do a swap would be very complicated if it wasn't for the fact that it's a standard contract. So you can trade them in the millions, in the billions, or in the trillions. And that's what happened in the 80s. The reason derivatives markets grew so much, and the reason many of you like derivatives, the reason you have courses on derivative pricing and all of that was caused by the fact that derivative contracts were standardized. They were recognized and you could trade them very quickly. If that wasn't the case, if derivatives continue to be over-the-counter contracts, every time you do a derivative will take months and months and months of negotiation. That means volumes will never grow. For volumes to grow, you need these contracts to be standardized. This just happened with carbon credits as stated in this graph by the Securities and Exchange Commission. Okay? So that's another reason why all of these things matter. I need you to be aware of the circumstances that have given rise to the creation of this course. Now, this is part of somehow a bigger thing that has been going on for a long time. And I want to revise that for you also because there's lessons to learn from history. There is an event that happened in May of 1990. I have here a newspaper clipping from the New York Times of May 24th, 1990. And what this does is it makes reference to a shocking action by Harvard Investment Management. Harvard University, as you know, has an endowment, the largest endowment in the world. Today is about $35 billion. So it's 3 times the size of the university pension plan that Barbara Swan is managing. Very big. In 1990, they did something that shocked the financial industry. They divested from tobacco stocks. Now, you may have seen movies, you may have read books. Tobacco stocks in the 80s were like the dot-coms of today. Everybody wanted to be in tobacco stocks. They were the most profitable companies. The sentence that was said was that you make them for a penny, you sell them for $1. Extremely profitable. Everybody wanted them. In fact, many hedge funds, they did all they could to own these tobacco companies. Barbarians at the Gates is a very famous book from that time, and it talks about the history of Philip Morris being acquired by Nabisco, the food company. So in the midst of that, Harvard Asset Management comes and says they are divesting from their tobacco stocks. It was like a shocker, like to say, you know what, I'm going to get rid of all of my technology stocks. I said, what? What are you doing? Why are you doing that? And the reasons were very interesting, and they're very relevant to understand what's happening today. They said that cigarettes are unhealthy and should not hold tobacco stock. This is interesting because this is a moral dilemma. Harvard Investment Management took an ethical position to get rid of their tobacco stock. And whereas that's true, they took an ethical position, I want to present another reason why they did it, something which is closer to your home, something which is closer to the way that you are learning things in other courses. Here is the evolution of a tobacco company, a large tobacco company, British American Tobacco, PLC, and the evolution of the S&P 500 since Harvard made their decision. Okay. What's as an investor, what's your comment about this graph? Anybody has a comment to say? One could say that it was a good decision because from 1990 until 2005 or so, the S&P 500 outperformed the tobacco stock. But that would be not relevant. Endowment funds, pension plans, they don't work with 5 or 10-year time horizons. They work with 30 or even 100-year time horizons. So the decision they made was clearly not driven by that. Okay, so that is perhaps an accident. Maybe Harvard was a short time happy and said, well, look, I mean, we made this decision and now, but that was not really what drove that. And in fact, if you look at the evolution over the year after that, then you can see that tobacco stocks continue to outperform the S&P 500 until 2018. What happened in 2018? Any guess? It was not COVID, by the way. So what happened then is this. There were substantial changes in regulation, making tobacco more difficult to sell. There was decreased demand. People stopped smoking. There was competition from alternative products, and then litigation risks. This caused the stock to drop. There was another issue here, and that was not the birth, but the growth of the ESG markets, which I'll describe later. Okay. Now, this sounds familiar. If you look at, or if you think about a lot of the industries affected by climate risk, we probably could expect regulation to take hold more strongly than it's doing it now. We expect decreased demand from alternative sources of energy, for example. We expect competition from alternative products like low carbon liquid fuels and litigation risks. The, the, the tobacco industry, as you know, they started to get sued shortly after Harvard made this decision, and they kept on losing every lawsuit. And today, if there is a lawsuit against the tobacco company, they will probably lose. And this decreases the value of the company. You could argue the same way about the companies involved in what we will call in this course climate risk. In fact, I think it's late last year, there was a shocking event in London. Someone sued personally the board of Shell, the oil company Shell, sued them. I don't think that lawsuit is going anywhere, but the fact is there. And there was a personal lawsuit. They didn't sue the company, they sued the board members individually. Okay, and you could conceive that one could just as well sue the shareholders for some type of social responsibility for something, in this case tobacco, or in our case perhaps fossil fuel. So this is what's brewing in the background, and financial firms are fully aware of this. Insurance companies, I'm not going to talk about this, I don't think, in this course, but insurance companies in Europe, for example, are regulated as to how, the type of investments they hold in their portfolio. And believe me, this drives the portfolio managers crazy, because there's a lot of oversight on the investments that they do. So these things have arrived already in climate-related contexts. Okay, so I'm going to show you here a very short video. I won't show you all of it, just the beginning, because I want you to see what Harvard is today. This is the same Harvard that divested from tobacco stocks in 1990. Okay, so 34 years later, this is what's happening at Harvard.
This is Democracy Now!, democracynow.org, The War and Peace Report. I'm Amy Goodman with Nermeen Sheikh.
We turn now to Harvard, where students are continuing to blockade key administration offices while calling on the school to divest from fossil fuels. Harvard has the largest endowment of any university in the world at $36.4 billion. The protest began on Sunday when students began blockading Massachusetts Hall, the school's central administrative building. Several alumni of Harvard have also taken part in the blockade, including Bill McKibben, the founder of the group 350.org, and former Colorado Senator Tim Wirth. The protests are being organized by the group Divest Harvard, which produced this video.
We are Divest Harvard. We're students, faculty, alumni, and members of the community calling on Harvard to divest from fossil fuel companies
in order to stigmatize the fossil fuel industry and open up space for political action on climate change.
Fossil fuel divestment means taking your money out of investments in fossil fuels and instead putting it into more socially responsible companies.
Our message is simple. If it's wrong to wreck the planet and threaten millions of lives, then it's wrong to profit from that destruction.
Harvard professor Drew Gilpin-Faust, whose office is in the blockaded Mass Hall, has spoken against divestment in 2013. She said the endowment should not be seen as a, quote, instrument to impel social or political change.
Okay, I'm going to leave it there. I'm going to end with this actual sentence, which is very relevant for us. This professor said that the endowment of Harvard should not have a social agenda. Something similar was said in 1990, and these things are very hard to debate. And I'm here not to debate that. Again, this is a course on mathematical finance. I am going to ignore not all, but most issues of public policy. There will be some that I will be addressing because they are very central to the quantitative finance that we'll be developing here. And I'm going to also not be addressing issues of environmental science, except as they are needed to understand what the problem is. I'm going to focus on the finance of this. And to do that, I'm going to, you probably played this game. I am assuming you've played this game, but I'm going to try to, I want to play again. I'm going to try to, I want to try to have a poll, see if you can, everybody, I want you to trade, okay? I want everybody to trade, and I want to be able to, if I see the results. So choice, they have two games here. And, okay, let me just see if I can do this. Okay. All right, so I'm going to give you a choice. We're going to play two games. These are trading games. You probably know them, okay? That's okay. It's not a problem. So in the game, we're gonna play the first game. The first game, I give you a choice. You're gonna make $900 for sure. Okay? You choose A, I give you $900. If you choose B, we gamble. And then you're going to have a 90% chance of making $1,000 or a 10% chance of making nothing. All right? So let me see if I can do a poll. All right. Please answer. I'm hoping everybody trades. It's a trade. You're making a choice. And you have to make a choice. You're in a situation where not doing anything is not an option. You have to do it. We will go through examples later where these choices, you will see, they will become real choices. Right now, they are theoretical choices with theoretical numbers. Okay. I would like everybody to vote. I still have some more people that can vote. No, that's it? Okay, so I don't know if you can see the results of this trade, but about 80% of you chose A. 80% of you went for the solution without risk. You just take $900 and you go home. No more gambling. Okay? 80%. This is about typical. This is what, if I do this often, and this is the type of result that that we get. So you can probably see the results on Zoom. I guess I don't see your perspective, but that's what I think you see. Okay, good. Now what I want to do, I'm going to play a different game now. In the next game, you're all, I mean, if you choose A, now you're going to lose $900 for sure. But if you choose B, you're going to lose $1,000 with a 90% chance, but there's a chance that you don't lose anything. Okay? And you have to, again, you're in this situation, you can't say, oh, I'm going to go back to game one, I like it more. No, that's not the point. Okay? You have to play game two now. You have to. Either you choose A or you choose B. I'm going to, hold on a second, I need to do one thing here. And I'm going to open the poll again. I'm very curious to see what we get here. So stop sharing. There we go. Back. All right. So what I want to do now is I'm going to issue the same game. A, B. This is game 2. All right, there we go. I think you can vote now. This is for game 2, okay? This is a trading game. All right. So you're faster trading this time. Most of you have traded already, and I can see that about 90% of you gambled. Very few of you just took your losses and went home. This is very interesting, and there's a lot of things to say. And I said this is not a course in environmental science. This is not a course on public policy. It's also not a course on psychology. Okay, although in this course, all of those things are going to come together. Now, what you've done here as a group collectively is you've done something very remarkable. Just share the results so you can see them. I'm assuming you can see the results. I don't know.
Yeah, we can see.
You can, right? Okay. No one has ever done this to me, so I don't see the results from a user perspective. Okay, and I don't know if I guess I'm a special user, or maybe the host or something, and that's why I don't see anything. All right, there you go. So we're done with that. And so what do we learn from here? There's a lot of things. There are actual courses on behavioral finance which are only on this. Okay, again, I'm not going to do that today, but this is going to be very, very relevant. Let me start with something, a very simple application of this. Let's say that you're confronted with a bad situation in which something bad could happen, like climate risk, right? So you can take two actions there. You can say, "Oh my God, um, choice B. I say I go for choice B, but choice B. Imagine that $1,000 becomes $1 million or something like that. Much worse. So you hate that, right? You say, well, the climate risk is going to be so bad that we're going to be, having really real losses and real difficulties, and we're going to die. Who knows? And then but maybe not, maybe nothing is going to happen. We're dealing with uncertainty, as I'll explain later, right? And your choice A would be, well, let's do something about that. Let's get some insurance. Let's spend some money. Let's spend some money to diminish the risks that could happen, which essentially is what a lot of the discourse, the public discourse on climate risk is. Let's fix the situation. Let's come up with new sources of energy. Let's spend some money. Or risk losing more money. Well, everybody's taking, like you have, many people are taking the risky situation. They are trying to gamble. The thing is that no one wanted to gamble when you have something good that you can grab. There you don't gamble, you go for it. This is something about the human brain. The human brain is, first of all, it's asymmetric. That's why we're alive. We need to pay a lot of attention to risk. We pay a lot of attention to bad things that could happen to us. We worry about things that will never happen. We worry and we act about that worry. But when it's time to confront losses, and then we don't. Okay, so I want to say more things about this, but this is a game we're going to play today. We're going to remember this game. And I'm going to use this game to go back to the trade decision that Harvard Investment Management did and try to understand it from a risk perspective. So here I have tobacco companies. They can make me a lot of money. I give that up. I don't want that money because there's a chance there's going to be lawsuits tomorrow and then I will lose it. Right? So let me ask, and this is a rhetorical question, you don't have to answer, but what is this? Is this a game 1 or a game 2? It's a game 2. I'm giving up something, so in other words, I'm paying. Tobacco companies are very profitable. Okay, I don't want them. That implies I'm paying a premium. I'm paying a premium because there's a chance that we'll lose a lot more in the future when lawsuits happen and maybe maybe my endowment fund gets hurt. So what Harvard Investment Management did is on game 2 they chose A, which is the reason that what they did was so shocking, right? Now, this is interesting because this is something that you do in every time you price a derivative. Every time in your risk management course, you're going to be doing this. This is the fundamental of finance. This is what finance is all about, is to know when to take risks, what risks to take, and sometimes you pay a price. When you buy an option, you pay for it. You never say, oh, no, I'm going to gamble. I'm not going to buy the option. I'm going to gamble. So the act of buying an option is an act of choosing A in game two. Professional investors are trained to do that. In fact, a lot of the pricing theories you're learning in MMF is so that when you go to game two, you choose A. Still, they're counterintuitive. Or you may say, well, the numbers were not right, which is possibly true. I'm not criticizing your decision. I'm not saying you've done anything wrong, by the way. Okay? But a 50-50 answer, 50-50 split, would be consistent with the fact that choice A and choice B are mathematically equivalent if it's not for the fact that you price risk differently. Okay? So let me continue with this discourse a little bit. I'm going to focus on more examples of that. And I want to tell you that this act of biting the bullet, paying a premium, and changing the future scenarios is something that started a long time ago, 40 years ago probably, and it had an early name called impact investing, which is to be generally aware of the consequence of your investment actions. Okay. Now this changed names and became what we call ESG, that I'll explain today, that gave rise to well-defined rule. It is giving rise to well-defined rules and procedures. Not yet. We're almost there, but not there yet. But it will eventually. And this is the whole area of sustainability that I want to eventually address in this course. So this is what this course is about. It's a different way of thinking. And a lot of what we're going to be doing here is we're going to be doing risk thinking. Risk thinking. So in that, I'm going to ask you, and I'm not going to do a poll, but I'm going to ask you a similar question to game two. This is very similar to game two. We're going to spend a lot of time on game two. Imagine you're at the airport and that's the plane you're going to catch. There's no refund, there's no cancellation. You have two choices, fly or not fly. By the way, there's a federal rule that says that when there's lightning, you don't fly. Okay, so, but that's in a certain sense because someone has gone through these choices and has created legislation. Since my objective is climate, I'm going to be eventually applying this to climate, but not yet. I want to stay in the area where we have more knowledge and we can make more informed decisions. So I'll ask you a question. Would you fly? In fact, let's do a poll. I want to know. You lose your flight. Okay, you lose your ticket. Whatever you paid, you lose. You're gonna have to either stay home, don't go to your destination, or buy another ticket. So I'm going to create another one. Okay, I'm gonna have to add a new one. One is fly. Second choice is no fly. There we go. So what? Okay, I'm trying to do the poll. I'm curious about what you will say here. Oh. Okay, there we go. Oh, I have to stop my share. Sorry, apparently I'm sharing a result. I'm sharing a poll. I can't see it. Am I still sharing the poll? The previous poll?
No, you're not.
No, I'm not, right? Well, Zoom is telling me I am. So, Ali, you're asking if we had travel insurance. No, the answer is no, we don't have anything, okay? We're taking a risk. We're taking...
Thanks.
Okay, so, but I can't, for some reason I can't. It looks like I'm sharing the previous poll. It doesn't let me do a new one. It's a pity. I was curious about the... No. Can we just... I may have to... Well... all right. Do me a favor then. I can't seem to be able to do this. Just answer yes or no in the chat. I want to have an idea. Yes or no. Yes, you fly. No, you don't fly. Yes, you fly. No, you don't fly. All right, that should be good. Most of you are not flying. So most of you are not flying. All right, good. So let me go through this and let's try to bring down some thinking. We're going to be thinking about this. The objective is to understand these things. So so this is an argument in favor. An argument is, probability says you're unlikely to have a problem. It's very unlikely this is going to happen. In fact, I can refer to physics. Faraday law will say that if lightning happens, it's going to go around the plane and continue its way. It's not going to bother you. In fact, you probably know if lightning hits a flying plane, nothing happens. Maybe a bit of a shake-up, but no, nothing happens. So that would be an argument in favor of flying. What's the argument against? If you're wrong, you die. Right? That tips the scale, and I suspect that's the reason why many of you said no. You're not gonna fly. But this argument probably seems reasonable. It seems familiar, right? So let me spend a little bit more time doing risk thinking. I'm going to redo trading. It's just that I'm going to be dealing with securities, which are not stocks, not options. I'm going to go back to how trading actually started. And I want to talk about what to do when you don't know what's going to happen. I want to say a few things and see what we learn from that. I'm going to give you an example. This is a true case. This actually happened. And some of you have heard this before. This is one of my most favorite examples. I use this to explain many things in finance, as some of you know. But some of you may not have seen this before. And it's very, very relevant for what we're talking about now. And it's something that happened in the city of Montreal. It's my very famous snow swap. Okay, so the city of Montreal spends about $100 million a year cleaning snow. And the way the snow is done is through a public tender where you have to select which months you want your streets cleaned. So if there is snow during those months, someone's going to come and clean it. A company is going to show up and with their trucks and they're going to take the snow away. But if your snow happens outside of that, then you're going to be stuck with potentially a very large cost. The year this swap was designed, this actually was done. Someone drafted this swap and it was agreed by the city and security. I'll tell you all the details in a minute. That year in Toronto, we had snow in April. Toronto does not buy protection in April. Toronto does something similar, and we don't buy protection in April. The reason is that in April, if it snows in a few hours, the sun comes up and then the whole snow just melts away. So why are you going to spend $20 million or something like that, right? But that year, after 3 days, Toronto was a mess. Trucks could not deliver food. So they ended up having to call the company, who charged Toronto, the city of Toronto, one half of next year's budget to clean a single snowfall in April. A disaster, okay? A financial disaster. So what someone did is realize that the ski resorts outside Montreal have the opposite problem. They want snow, as much of it as possible, and as early and as late as possible. Now, the city of Montreal does not have any issues with this contract in the month of January. Of course, in January, you're going to have that contract. But November, December, April, even May are, you may need them, but perhaps in May, you're just throwing money away. So what someone had the idea is the swap is real. This actually happened. The numbers I don't know. The numbers I made up. But the concept of the swap is real, okay? And it works something like as follows. If there's no snow, the city will pay the ski resort a fee. I'm going to say $10 million for that month. And if there is snow, then the ski resort will give the city $10 million to help them pay for that cleaning fee. The ski resort will be very happy when that happens because they have plenty of revenue. But if there's no snow, the city is happy. They don't have to call anybody, and they're not going to spend any money. They saved good money on that cleaning contract, and some of that they are giving to the ski resort because the ski resort is going to have losses, substantial losses, due to decreased revenue. Is that clear? This is a swap. Now, this is not an ISDA swap. This is not the swap that Bank A does with Bank B, making a reference to the ISDA conditions, and therefore they can do this swap in a minute. This is a swap which is very non-standard. One person had to go to the city and the ski resort and negotiate and get the swap done as a contract. I don't know how many pages, but this took months, probably a year, who knows, right? And something interesting happened. The city and the ski resort did not agree on where to measure the snow. They didn't agree. They agreed with everything, the financials, but the city said they wanted to measure the precipitation in the city. The ski resort said, no, I want to measure it in the ski resort. And as a result of that, the deal died. They didn't reach an agreement. Now, this is interesting. Oh, some of you may think, oh, this is a weather derivative. So, of course, we're talking about this in climate risk. The answer is no, not yet. These weather derivatives will be very useful for a climate risk management, but we're not there yet. We're still trying to understand what to do when we don't know what to do, or what to do when we don't know what's going to happen. We're trying to understand how to deal with uncertainty. This is how options were created. This is how the first swaps, not snow swaps, interest rate swaps were created. This was exactly the same reason and exactly the same thinking. I'm just going through that with an example which is out there. All right. So it seems that the situation has no remedy, but let's think about it from a risk trade perspective. Now, the game that we're playing is the game that the city of Montreal is in and the game that the ski resort is in. So the ski resort could decide to not gamble. They're just going to take, let's say, a $10 million gain. They're going to make a lot of money if there's a lot of snow and they don't enter into a swap. But they say, you know what? No, I'll enter into a swap. I'll guarantee some gains. And then I'm not going to gamble. If I gamble, let's say that if I have snow, I'm going to make $50 million. There's a probability of that, 20%. And if there's no snow, I am going to be in deep trouble. So let's say, and again, these are made up numbers. I made the numbers so that they fit my previous example. You understand what I'm doing, I hope. So the ski resort could decide to not gamble and then just enter into a swap agreement, or gamble and say, I don't care for that. I'll take my chances. And according to what you did, most of the time the ski resort will just say, no gamble, I'll just take my money. So the ski resort might be easier to convince to enter into this trade. But now when I go to the city of Montreal, you can think that the city of Montreal also decides to, choice A is, no gamble, I'm just going to spend $10 million, enter into a swap. Or say, no, I'm going to gamble. If there is snow, I will lose a lot of money, but if there's no snow, I save money. What shall I do? Well, if they do what you did, then the city of Montreal is going to decide to gamble. Okay, now, that's a way to codify. I'm not going to get into this. I'm not going to get into the decision making of the city and the ski resort. What I want to do is I want to now create a new instrument. This is the important part. I want to create a new instrument, which is actually going to be another swap, but different, because I'm going to give the city of Montreal and the ski resort exactly the swap they wanted. They measure the precipitation at the city or at the ski resort, and now I take the risk. I'm the trader now. Okay, so now we're starting to share the risk between all of the participants here. And again, ignore the fact that we're talking about snow. This is not about global warming. This is just about finance. And I'm not going to do that for free. I'm going to charge some money. I always need to charge some money. Every time I take risk, I need to charge some money. And in this case, I'm going to charge 10% of the cash flows. I have no idea if they would go for that, but for the purpose of this example that I'm presenting here, that's what I'm going to assume. I'm going to assume a 10% fee on the overall cash flows. Okay, so I'm going to risk $20 million. I'm going to make a $2 million fee. That's a rate of return of 2%, of course, in addition to interest rates. Okay, so that's the deal that we would do. Would you do it? So we'll do a poll. I'm not going to do a poll on this because I suspect many of you have already seen this and I think you know the answer. So let's go through the analysis. The analysis is what's interesting for us. I'm going to assume a certain positive correlation between the snow at the city and the snow at the ski resort. I expect the snow precipitation to be similar. I'm not going to calibrate this number. I'm just going to pick a number for the purpose of this example. If this was a real case, I will do my analysis, I'll get some data, and I'll get something going. But with a 50% probability, what will happen is that there's a 75% chance that there's exactly the same event. Snow, no snow. I get money from one and I give it to the other. I don't know who I get money from. I don't know who I give money to. I don't care. I make my 10% free. I make $2 million. There's a 12.5% chance that I actually receive payments from both. There's snow in the mountains and no snow in the city, and then both pay me. Okay, and because this is not a course on environmental science, I'm not talking about whether more snow falls on the mountains than in the cities. I'm not concerned with that. I'm assuming that these are the same. Okay, but these are random events. This could happen with a probability of 12.5%. And also with a 12.5% probability, I will have to pay both, in which case I lose $18 million. 10 and 10 minus 2 that they pay me as a fee. So now this looks like an investment we can analyze. Would you invest in it? Would you invest in it? I don't think I can do another poll. For some reason I'm still... Oh, stop sharing. Oh yeah, there we go. I think I can do another poll now. Yeah. I can do another poll. Okay. So I wanna know. Again, some of you may have seen this already, but I want to know your trading mentality. So I'm going to say this. I'm going to call this a snow swap trade. Choice one is, will you invest? Yeah, choice one is yes. No, I am assuming that you have $20 million, okay? I'm assuming you have $20 million. Okay, there we go. So I'm going to now launch this. Tell me if you would trade, if you would actually do this swap. You're going to make 10% return in addition to interest rate because your money is going to be collecting risk-free rates while the year goes by and cash flows are determined. This is a trading game. I would like some more people decide. If you don't know what to do, just follow your instincts. I don't expect anybody to do some of you are doing calculations, but I don't expect anybody to do a calculation. Just tell me what goes into your mind. So most of you will trade. Most of you will trade. Very interesting. Because I'm going to share my results. That's you can see the results, yes. So the vast majority of you will trade. Very interesting. Very interesting. Because this is what let's look through the investment parameters. We're investing $20 million. Our average return is 10%. 10% is very good. Oh, it's wonderful, eh? 10%. In addition to interest rates, very rare to fund an investment which is so good as that. The volatility is 50%. I have the formula here. I'm not going to go through that. I guess you're good enough to understand that, right? Volatility of 50%, average return of 10%. Is that really a good deal? My Sharpe ratio is 0.2. It's actually not a good deal. I would not invest. I would not invest. The risk is too high. Uh-oh. For some reason, most of you invested. That's okay. I would not invest. Is this clear? Is this... I don't know if... Yes. So I'm hoping that you're following these things. I mean, this is very real. Okay. So, Ali, yes?
Yeah, a good question. So, like, would you look at the payoff? Because, like, when you look at the weighted average of the probabilities and the cash flow is a 2 million positive payoff.
Right. Yes, that's right. Yes. So the average return is 10%. That's $2 million of the 20 I put at risk.
Yeah, but so you base your decision based on the Sharpe ratio.
Well, I'm looking for a simplified. So my answer would be yes. Right now, that's what I would do. I would say the Sharpe ratio is 0.2, is a very small Sharpe ratio. So my money is better invested in the stock market, in the bond market. They have better Sharpe ratio. You may say, oh, why the Sharpe ratio, this or that. Oh, well, look, I mean, this is not a cost of investments. Okay, if this was, maybe I will get a deeper analysis on that. But I would consider the risk to be too high.
Yeah, thanks.
Okay. So if this is not clear, let me just move to the next one. What I'm going to do now is I'm going to get real smart, and I'm going to do the same swap 100 times over. I'm going to go to 100 cities, and I'm going to go to 100 ski resorts. And I'm going to do my investment. Okay. Again, this is not, again, I'm talking about snow. This is not, there's no relationship between the climate title of my course and the fact that I have snow. I could have taken interest rates or something like that. It's just that I wanted a derivative which is not an ISDA derivative, and the snow swap is not an ISDA derivative. Okay. So when I say here it's independent of global warming, I'm not saying anything about global warming yet. I'll talk about that in the hour that's coming. All right. I just want you to understand that if there is global warming, it'll be very bad, but not for my portfolio. That just means that I'll be giving a lot of money to ski resorts, and I'm not going to be giving money to cities. I'll get money from cities because I expect less snow. Okay. But my portfolio is going to be just as balanced. I get, because I want to avoid the fact that I have to pay both. That's where I want to avoid. And global warming is not going to alter that. Okay? That will be acted by randomness. So if I have 100 swaps, I have the names of the swaps and the cities here. Sorry, I have the names of the counterparties here, both ski resorts as well as cities. Imagine that. Okay, 100 of them. Then what happens? My investment parameters have suddenly changed because my rate of return continues to be 10%. I have to invest $2 billion. Oh, doesn't matter. Let's assume we have it. Let's assume we have it. Again, this is not a course on investments. It's a course about decision making. So I'm going to assume I have it. My volatility is now 5% because with 10 independent swaps, when I put them together as a portfolio, the volatility decreases by the square root of 100, which is 10. So it's not 50, it's 5. And my Sharpe ratio is 2. would you invest? Let me see if I can, I don't know if I can launch the same poll. Let me see if I can, let me see if I can do that. Okay, I'm relaunching that. And now I'm asking if you would invest. But now this refers to the whole portfolio, not to just one swap, okay? Of course, if you liked one swap, of course you're gonna love 100 swaps. Well, you're gonna like it 100 times more, right? I don't know, maybe someone got scared and doesn't want to invest now. Okay, so it looks like everybody wants to invest. No one is afraid of this. No one is afraid of this. Very good. I'm gonna end it now. I'm gonna show the results. You can see them. Fantastic. Fantastic. Good. Okay, well done. Okay. I'm going to stop sharing. I may do some more polls. In fact, I will do more polls, I think. All right. So, so this is good. And we've learned, well, let me move forward. Let me tell you how you organize information when you're going to make decisions under uncertainty. And this is going to apply to climate risk. This will apply to climate. I'm just organizing the information now. I'm going to organize it differently. One of the things that you learn if you look at the book by Nassim Taleb, which is in my bibliography list in the website, is that when you're in a situation with uncertainty, you want to organize your information into three pieces of information. Actually, the last one is not really a piece of information. You will see. The first one is you need to know what you know. This is what's called the known knowns, what you know. Then you rate your known unknowns, things that you would like to know but you don't yet know, the uncertainties. And this is where probability comes into place. Okay, so I have to say that when it comes to climate risk, the known knowns are very few, but everybody gets them right. And there's no disagreement there. The known knowns, there's no disagreement. Everybody gets them right, but there are very few of them. Most of the issues in climate are known unknowns, things that we don't know. But every time you have a situation of uncertainty, every time you're dealing with risk, there's always the unknown unknowns. Things that we don't yet know, we need to know. In fact, this column is always empty. There's nothing there until you're done and then you can reflect on what happened. Okay, so in the book by Taleb, he uses the example of a turkey self-analysis in November. Known knowns, I have a good life. Food, home is great. Life is wonderful, right? Known unknowns, how long will it last? I don't know. And the unknown unknowns is Thanksgiving is coming. That's in the book. So you can look at all situations of uncertainty like that. The Silicon Valley Bank in 2021. Known knowns, rates are low, lots of deposits, excess cash, very good regulatory capital. They invest their cash in the lowest risk investment possible in bonds. These are the known knowns. Were the known unknowns? Will rates go up? Yes or no? Yes or no? Yes or no? People were talking, so people will say yes, we will say no. Will my deposits decrease? Well, the deposits are there, they've been very stable. Is my leverage adequate? I think they had 50 times leverage. Is adequate? Well, it's in the norm, this is what people have had. Unknown unknowns, rates will increase by 5% in a few months. And at the same time, my deposits will decrease. You can look at the subprime crisis of 2007 and 8 in the same way. There's always unknown things that happen that we did not know. The unknown unknowns, what they do is they always increase the risk. The unknown unknowns, what they always do is they should increase what we will call the credit premium. Sorry, the risk premium. Okay, the unknown unknowns are reasons to always choose A's, not B's, when we make our trading game. The unknown unknowns we can account for and we can calculate just like we did with the snow swap, right? But the known unknowns, what they do is they always make your trades more expensive. Okay, so back to our snow swap. Imagine that in 2008, actually this happened. You're reading in the Global Mail about a company called IntraWest that is going to go bankrupt. You may not know what IntraWest is, but let me tell you, IntraWest owns all of the ski resorts in your portfolio. What then? What if IntraWest goes bankrupt? At that point, you're praying for global warming because you're not going to get a dollar from any of the ski resorts, right? So in this case, we have the known knowns. Snow in cities and mountains are similar. We have the unknown, so we have the known unknowns. They're not exactly the same. Difference in precipitation are independent from Toronto to Montreal to this and that. The unknown unknowns is default. The cities or the ski resort could end up not paying. We didn't realize that. So we made the wrong trade or we charged the wrong price because we were not aware of that. Okay. Now, so let me tell you how this is discussed when people talk about climate risk from a risk management perspective. I'm not talking about environmental science or public policy. From a risk management perspective, this is the issue. We have known knowns, which I'll describe. Okay, CO2 is a gas that warms up with the sun rays. It's the same thing that happens when you take your plate with food and you put it into the microwave. You know what happens, right? When you take food and put it into the microwave, the plate doesn't get hot. The food does. Why is that? You know why? Because the food has water, and water has hydrogen, oxygen, oxygen, H2O, has H2O. And that H2O, the microwaves that come from the machine, make it spin very fast. So it gets warm. But the rest of the plate doesn't have any material that is excited by the microwaves. So it stays cold. When the sun hits the gases in the atmosphere, it does the same thing as the water in the CO2, the carbon dioxide. By the way, it does the same thing to the water in the atmosphere. The water in the atmosphere also gets very hot. It's actually one of the main greenhouse gases, water in the atmosphere. That gets hot too. And so does methane, and so does nitrous oxide. All of these gases in the atmosphere get hot by the action of the radiation of the sun. That we know. This is done in physics experiments, this is done in labs, and this is, no one questions it. This is true. Okay? And this is what led scientists to warn about greenhouse gases. All of these are greenhouse gases. There are more, but these are greenhouse gases. They get hot when the sun hits them. So they're going to raise them. They're going to raise the temperature. And once you raise the temperature, then we don't know what's going to happen. These are the known unknowns. The temperature of the atmosphere will probably go up because all these gases go up. And we've done lab experiments. There's a little bit of CO2, there's a lot of water, there's very little methane, but they become so hot that it's actually going to have an impact. How much? We don't know. Because that's going to increase the volatility of every environmental action. It's going to create more wind, more rainfall. Everything related to volatility is going to go up, right? And this would probably rise the temperature around the Earth, which will then make the polar caps melt, increasing the ocean levels. And this may make the Gulf Stream reverse its course, and other things. All of these are documented, but they are maybes. So we're back into game 2, choice B, right? And some organizations that I'll describe have done a lot of analysis, but the analysis that we have here is risk analysis. Okay, there's supercomputing, high performance computing models that try to model what the atmosphere is going to do over the next decades. That's extremely difficult to do, even for a high-performance computer. You have the Navier-Stokes equation, it's extremely complicated. Everything seems to indicate that with high probability, all of these things will happen. The temperature of the Earth will rise and this and that. But there's a probability that it doesn't. Maybe very small, but there's a probability that it doesn't. I want to show you a video, if not today, next time, of a scientist that has done some models and says the probability that this will happen is 20%. Maybe it's 50, maybe it's 90. It's not 100. Okay, he says it's 20. Let's take that at face value. Let's say it's 20%. These known unknowns will happen. 20%. Let's say it's a 20% chance that you jump onto that airplane and it crashes. Will you fly? I'm going to ask you. I want to use the poll that I couldn't do. And I'm going to do that. Would you take an airplane if... I may have to edit this. Give me a minute. Flying or flying. 20% chance of crashing. Only 20%, not 50. 50%. Okay, there we go. See what answers I get. Okay. So 3 people are flying. 5 people are flying. 6 people. So is MMF treating you so badly that you want to take our airplane? Really? Life as a student must be really, really hard. You get my point, right? You get my point. I'm going to show the results. Yeah, so 6 people will fly. That's a way to not have to take any more exams at MMF, right? Okay, stop sharing. There we go. All right. So this is how you do risk theory. I hope we learned that. This is how you do risk theory. And everything we do, not just climate, but option trading, stock purchasing, all of that, investing, is the theory of risk turned into dollars. That's what it is. When it comes to climate risk, we're going to be confronted with very similar issues. And this is important to highlight, which is that climate risk is a risk theory. The engineering is done. There's no issue with the engineering. Okay? The engineering is very clear, and everybody agrees to that. It's the risk aspects of that. That's where some people choose A, some people choose B. And, well, so let me continue. So obviously, unknown unknowns we don't know because it hasn't happened yet. Otherwise, it would not be there, right? But this is the way you think about these things. So when it comes to risk thinking, I mean, 6 of you will take your flight. Okay, will take your flight. 20% chance of dying. But this is how we're going to write this down. We have my choice. I will miss my flight with a 100% chance. It's going to cost me money. 6 of you will say, no way I'm going to pay for that. No way. Get me on that plane. I'm leaving. Okay. And then the rest of you would say, I'm going to abort my flight. Sorry, the other way around. I said it wrong. I forgot the numbers. I think 15 of you said, I'm going to miss my flight. I lose my money. No problem. But I'm alive. I'm fine. But 6 of you have said, no, I'll board that flight. If I'm lucky, I die. But if I'm lucky, nothing happens. I save my ticket and I get to my destination. Okay? I get to eat that turkey with my family for Thanksgiving or whatever it is that you're doing. That's the decision that we're making. That is what you decided in your poll that you were going to do. And the same thing will happen when you're doing climate risk. And the thing about these things, and now I'm going back to the game of finance, is that I can start to play with those numbers. And that's what brokers do. This is what market making is all about. right? Especially if I know what people want. So I can go to game one and I can start to change my numbers. I'm not going to run the poll. I suspect your choices are not going to change very much because I changed these very small numbers here. I suspect your decision will also not change very much because I changed these numbers here. I changed them very, very slightly, right? But if I can change this number so that you change your mind and everybody chooses A, everybody in game one chooses A, and everybody in game two chooses also A, then I, as a broker, I make a huge amount of money. I make $1 every time I trade, for sure. I just need everybody to make the same trade. But if you gamble, I make money too, with some probability. This is arbitrage, right? So if you know what people decide, then you can take choices. And now note, I am adopting a financial perspective on this. Again, not an environmental perspective and not a public policy perspective. So in a certain sense, you can think that this is why Jamie Dimon and Victor Dodit said what they said, because this is their business. That's what they do. Barbara Svan is different because she's an investor. She's not a broker, right? So she's an investor. She's more like on the Harvard side, and she probably sees value in game two choosing A because she considers that to be the right decision. Okay, so this is the perspective we're going to be adopting on these things. But now we can easily move forward with this and then get to discuss insurance premium, because this is what we're talking about now. We're talking about insurance premium. Not always we have insurance premium, like if the temperature of the Earth increases by 10 degrees and then we disappear as a species, then, well, there's no way to prevent that. There's no amount of money you can pay for that. The only thing you can do is you can do mitigation. But for us, it's going to be the same thing. Okay? Mitigation cost or option premium are going to be the same things for us. And now we can look at choice A in game two. Okay? The game of losses, the game of death. That's the game, not the game of life, the game of death. That's the goal we're focusing on. There, we can rationalize our decision to take action at some cost and saying that is the premium I'm going to pay. If I gamble, then I have loss value and, of course, with a certain probability. And I need to know those numbers. I need to know the value and the probability before I make the decision. If the probability is insignificant, then I gamble. But if it's significant and if the loss is huge, then I don't. This is what drives our decision. So our decision is driven by three variables that we have here. And these are the variables I want to discuss now. Okay? The mitigation cost or option premium, which is what gets me out of trouble. And if I'm in trouble, the probability that something will happen and the amount of money I will lose. That's how we're going to be looking at this. Okay? That's how insurance works. So we're going to develop a rational risk theory and some basic facts that maybe you know, maybe you don't. I would assume that you do, but I cannot be sure. One might think that the insurance premium or the mitigation cost should be like the probability of loss times the loss amount. You might think that. That's not true. And I'm going to show you. I'm going to do a slightly more realistic picture of this, where I don't have just two scenarios. I have an arbitrary number of them. They could be infinite. And each of those scenarios will have a certain probability or probability density if I have infinitely many of them. And they lead to losses which are different under each scenario. So in other words, I have a probability space with events and a measure, and I have losses which are random variables, which are functions of that probability space. You're with me, right? This is probability theory. You've seen this, you know this. So one might think from this perspective that the insurance premium should be comparable to the expectation of the losses. That's how we thought, or that's how some of you thought when you decided to enter into the single snow swap game. Wrong decision. We saw it was too expensive, right? So this is not how you make these decisions. This might be true when risks are diversifiable if you do enough of them. That's what we did with the snow swap. We diversified it and then it became closer to the truth. But if the risks are not diversifiable, this underestimates the mitigation cost. And that's what happens with climate risk. Climate risk is not a diversifiable risk. Therefore, the mitigation cost is allowed to be a lot higher before it's worth your while. This simple probabilistic approach does not work. This approach will typically underestimate the insurance premium, sometimes by a lot. I have an example for you, a simple example, not related to climate, okay? We'll have to add a premium, a risk premium on top of that expectation of losses. By the way, when you see, this is very well known in credit risk. In credit risk, you never trade on the insurance premium only. You will lose your shirt if you do that, okay? I have the example of auto insurance. It's very simple and everybody will understand it. I have the sample assumptions. I'm going to assume that the expected value of a claim, of an auto claim, an accident, is $1,000. It's a 10% chance that I get a $10,000 claim. That's what I mean. Okay, so a claim, very simple, Bernoulli. Either you claim or you don't. You claim 10,000, you don't, and that happens with probability 10%. That gives me an expected value for the expected claim for the policy of $1,000. Okay, very simple. Two events. I don't have a whole continuum or anything, or a Gaussian event. No, simple, two events. So with that, imagine I sell a single policy, no diversification whatsoever. When I do that, the result is a Bernoulli that has mean 1,000, standard deviation 300. That's the result. It's a Bernoulli distribution. Can I charge $1,000 for my insurance policy? Can I charge the expected value? With 10% chance, I got a business. 10% chance, I got a business. Too high. I'm not going to do it. I am not going to do it. I'm not going to take that risk. Can I charge $1,100 for the? I'm charging now more than the expected loss. Can I charge that? Not really. The probability is almost 10% that I got a business. So non-diversifiable risks can be very, very costly. Very, very costly. Let's say I diversify. Let's say I sell 1,000,000 policies. 1,000,000. With 1,000,000 policies, the result is a normal distribution with mean 1 billion and standard deviation 300,000, or a Bernoulli which is approximated by a normal distribution very, very well. Okay. Can I charge $1,000? No. If I do that, I go out of business with 50% probability. I cannot charge the mean. Even then, I cannot charge. Even when it's very diversifiable, I cannot charge the mean. But can I charge $1,100? That I can do. That I can do. Because then the probability I go out of business is 0.13%, and most likely I make a lot of money. And this is a very profitable decision. Diversifiable risk and non-diversifiable risk are completely different. And we think about them at this level very differently. Of course, all of this can be quantified. All of this can be quantified, and in fact, what I can do, I can say that I'm going to price my risk, given a random variable of losses, as the expected loss plus a piece of the standard deviation. That's one way to resolve that. That's how, for example, credit risk was originally treated. As my standard deviation gets smaller, I'm more profitable, I can be more competitive for my pricing. Okay, this is how it usually works. So when I show you the video where you see that the probability of natural disasters is at least 20%, 20% is very big, is huge, because that risk is not diversifiable. That means that the mitigation cost associated with that could be much, much higher, and it still is a good trade. Okay? So to summarize this, the insurance premium or the mitigation cost for risks is going to be a function of two things: the expected losses, obviously, but also the standard deviation. And there we have to price the risk somehow. The constant alpha is the unit price of risk that has that have been under consideration. So this now becomes the building block for impact investment, which is impact investing, which is the investing that takes into account specific social benefits or other environmental effects in addition to your financial gains. Okay? And the thinking is very different because we have a financial thinking and then we have some other mitigation cost thinking that will lead to that. And this is what has become a new liability in the world of finance, which is what I called sustainability in general terms. Okay? Sustainability in general terms. It's a new liability. And because it's a new liability, like all financial, all liabilities, it needs to be priced. It needs to be taken into account into your ALM, into your asset liability management policies and this and that, knowing that this liability is not diversifiable, therefore the cost is going to be much higher. And this can be put into the context of the Sustainable Development Goals of the United Nations. Climate is one of them. There's 17 of them. I have, I don't know if I have a video. All of these videos that I have today are in my I have a playlist called Climate Risk in my YouTube channel. You can just watch them. There's, I don't know, a lot of them. Some are good, some are bad. They're all interesting. They're all there for a reason. Okay, there's even some which are just funny. They're there for a reason too. So you can watch them on your own. But these are some of the points that matter. So climate risk is the one that is very discussed. But for example, from my perspective, and now talking as an environmental science amateur, water is far more important for me. But why am I not having a course on water risk? Because in water there is no Article 2.1c. There is no such thing as a Paris Accord with an Article 2.1c. The reason we have a climate risk course is because there is a Article 2.1c of the Paris Accord, and the SEC just came out in March saying that these are derivatives, and therefore they're going to be traded. That's why. Okay? That's why I'm doing this. But I personally think that water is a bigger deal. We'll probably see something similar to this, probably even bigger with water than climate. Especially if we start to create new sources of energy and this and that. Water is much, much more problematic. My opinion. I could be wrong. Actually, it's not just my opinion. It's the opinion also of my friends who actually know about environmental science. I don't. I just learned from them. Okay? But there's no Article 2.1c in any water accord that I know. That's why we're talking about climate, because these trillions of dollars are going towards climate. They're not going towards water, not yet. Okay? All right, so I have here a simple video. I think I'm going to skip it. You can watch it yourself. What I want to do is I want to go beyond this video and to tell you that these 17 Sustainable Development Goals of the United Nations with its associated 169 targets have been codified into something that the financial industry, in particular the investment industry, takes very, very seriously. And that's the E, S, and G protocols that I mentioned to you earlier. Okay, I will mention to them. I won't have time to tell. I will have time to define them for you and to tell you how they play a role. There is a lot of negative press about them, and in fact, I suspect they are about to disappear and replaced by something better. But hasn't happened yet. They're still out there. They're still regulated. They're still implemented. So the first is the E pillar. The E word has to do with the environment. And some of those targets are listed here. Is the use of dependence of fossil fuels, the use of management of water and other resources, pollution, climate change, hazardous materials, carbon footprint, and renewable energies, for example. Then on the S pillar, what we have is employment equality, gender diversity, product safety, employee health and safety, training and development, animal testing, physical and mental health, supply chain transparency, human rights and privacy issues. These are things that 193 nations have said they are important. And they're all under the S pillar. These are tags, classifications, which are done and they affect investments, they affect the value of investments. And on the G pillar, G is all the stuff that has to do with governance, compensation of employee and executives, board and company diversity, the strategy and accounting standards, bribery, removal of bribery, removal of corruption, removal of fraud, things like that. Okay, these are under the G. And these are also elements which they don't translate into money, but they are avoided by the financial sector for a number of reasons. And back to climate, a lot of the climate policy that we will discuss here, or at least the policy that affects what or creates what we'll be discussing here, comes from the IPCC, the Intergovernmental Panel on Climate Change. They won the Nobel Prize for Peace Prize a few years ago. The Financial Stability Board. I may look at others. These are the two main ones. And what they have said is that greenhouse gas concentration levels must be reduced. That's what they say. This is going to affect all market actors and all sectors of the economy which produce greenhouse gases from their processes, the energy system they rely on, the products and services they produce, and that affects their service providers. And this is why Jamie Dimon said what he said in that quote, because this affects the banks. Now, there's 6 emission gases which are targets. I mentioned some of them already. Carbon dioxide, methane, nitrous oxide, hydrofluorocarbons. These are very interesting because they were originally targeted as they were thinning the ozone layer. These gases interact with ozone, not only get hot, they also interact with ozone. Because of that, they've been phased out. Because of that, we don't talk about the ozone layer so much anymore. Apparently it's coming back. But they also have a very big influence on global warming, perfluorocarbons and sulfur hexafluoride, SF6. Okay. Now these have a global warming potential, which is very interesting. I want to go through this with you. This is, I mentioned water is one of the biggest global warming agents, but it's not mentioned here. Why? Because water has a half-life in the atmosphere which is very short. In about a week, it just rains and goes away. It doesn't stay there. CO2 stays there for more than 100 years. It just doesn't go away. So if the sun rays are hitting the earth every day, CO2 keeps spinning and spinning and spinning and getting warmer, and it has nowhere to go. It's just there. CO2 is produced or has been produced by natural causes for forever. Forever. In fact, they say, as far as I know, it's a conjecture. I don't know if it's known to be true that at some point during volcanic eruptions, the CO2 just peaked. It was so high that that's when photosynthesis happened almost by chance, and then plants developed. And that happened apparently very shortly after life was created on Earth. That's what I read. I don't know if it's true. But the problem with CO2 is that it's created today mostly by actions of humans, what is called anthropogenic activity. For example, every time you create concrete, cement, you release CO2. Why? Because concrete, you have to heat limestone to like 1,000 degrees, and that's done by burning fossil fuels that release CO2. Deforestation, it doesn't, I mean, if you have a fire, yes, the fire releases all the carbon in the tree trunks into the atmosphere, but also we rely on a stable absorption of CO2 from trees. Deforestation alters that and creates a net increase to emissions just because the capture is not there. Okay. And CO2 is given a number 1 in the global warming potential scale. In other words, it's the one to whom we compare the rest of the gases. Okay, so methane, for example, which is also produced under natural circumstances by animals, we produce it too. Digestion produces methane. It's produced in an anthropogenic manner through landfills, oil and natural gas systems, agricultural activities, and so on and so forth. So the thing with methane is that the global warming potential is much worse than CO2. It's 80. It gets hot 80 times. The molecules spin somehow 80 times faster than CO2. The good thing is that it has a half-life of about 10 years. It interacts with the oxygen in the atmosphere and then it becomes CO2. So, which is going to be there forever, but at least the global warming potential is not so high. So methane is a different kind of gas. Now, nitrous oxide is also produced naturally. Today, from an anthropogenic perspective, it's produced by agriculture mostly. The global warming potential is very bad. Look at it, 300 times that of CO2. And it doesn't oxide easily. It stays there for a very long time. So it's much worse. All of these things that I'm telling you have impact on industries, impact on finance, immediate impact. On the nitrous oxide side of things, there's something very interesting that developed. You may have followed that. You may know, I'm sure you know more about cars than I do. I don't know much about cars, but diesel cars for a long time were considered to be better for the environment, for emissions in particular, than gasoline cars. And the reason is that they're more efficient, they burn less fuel, so the emission footprint is about half. Okay? The problem is that they emit N2O, they emit nitrous oxide, and that's much worse. Look at that, look at those numbers, right? So then they became environmentally unfriendly. And then what we had is a situation which we're going to see more and more of, which is we had engineering, geoengineering, or engineering advances that produces a chemical that you can add to the diesel fuel that reduces the nitrous oxide. Okay, and it has a commercial name called, I think it's AdBlue. It may have different names, different countries. I don't know. But this is a lot of the innovation that's happening today has to do with a lot of these things. These things matter today. And when it comes to the money flows, I mentioned earlier about ESG bonds, ESG rated bonds, which is where we're going towards. All these things matter. All these have a very big impact on that. And this type of engineering are attracting a lot of investments. And some of the bigger deals today are related to these things that we're talking about. Okay, these are becoming natural attractions for investments. You bet UPP, University Pension Plan, is in their private equity portfolio. I assume they do a lot of these things there. Okay, and so these three are natural gases, which are the targets for the global warming gas emission agenda. And then we have three which are not natural. They are produced only by humans. The first is the hydrofluorocarbons that I mentioned earlier, that's what Freon is made of. So the liquid that goes into refrigerators, air conditioning systems, this is what that was. We don't use them anymore. The global warming potential is 1,000 times that of CO2. It has a half-life which is not very large. It's 1 to 30 years. That's why the ozone layer, once you reduce this, comes back, because these gases, they become something else. The perfluorocarbons those are nasty. They have 10,000 times global warming potential, and they stay there for thousands of years. And they're produced when you make aluminum. Okay, so the production of aluminum is not only that it may produce CO2, no, it has this impact, it produces these things, and these are much, much worse. And then sulfur hexafluoride, 25 times global warming potential, and a half-life which is 3,000 years. So, and this is produced when you create electrical insulators and things like that. This is the target of those policy groups, and this is what is going to be aimed to be reduced. Now, there's something here, this is very close to my heart. We're not going to be telling you now, and that is contributors to emissions. This is something which, this is where we see the real impact of these policies, and this is if you work on an insurance company, if you work in an asset management company, certainly an insurance company, all of these things are going to matter. Okay, and very soon it's going to affect the bank loans and many of the other activities that we have, which is that contributors to greenhouse emissions are going to be all organizations that have emission generating industrial processes, environments which consume heat and energy, like for example universities, power producer groups which supply energy even if they don't burn it. Okay, all of these are considered to be contributors to greenhouse emissions. And by the way, in your risk management course, you will see all of this from a different perspective, and this is what will be called, I think, is scope 1. I think you will call it like that, scope 1 emissions, which are direct. Food and agriculture industries, which also produce emissions. We have a lot of them in Canada, scope 1. And then this is this is what I do my research on. Okay, I will end with this. This is something that I could spend hours and hours and hours talking about this. What you have here is a table which is very oftentimes used to point fingers at, where are the emissions coming from? Who should be lowering their emissions? When these countries go to the meetings of the United Nations called COP, then and the Paris Accord is people pointing at you reduce, and then when you look at the countries that produce CO2, it's very often mentioned that China is the #1 producer, 10 gigatons, followed by the United States at 5 gigatons. And very often, this is it's creating this negative sentiment towards China, which I find very funny, because when you divide the emissions per people by people, so the per capita emissions, the country that suddenly shoots up is Canada. It's #7. Okay. And why is the reason? The reason is that Canada is a country that has a lot of agriculture, and we are very, very, very few people. So you divide by a very small number. So what does this mean? That means that these tables mean nothing. And this is very important. I don't know if you know Paul Erdos, the Hungarian mathematician. He has a very good sentence. He says, a mathematician is not someone who can add. It's someone who knows when to add. Some of your mathematicians, I'm sure your friends and your relatives have probably told you, because you're a mathematician, you can calculate things in your head very quickly, right? And that's not true. What mathematicians know is they know when you have to add, when you have to subtract, when you have to multiply, when you have to divide, or do something more complicated. Then any calculator can do them. But you have to know when to add and when to divide and when to multiply. And that's where these numbers don't make any sense. Here you are adding, then you're dividing, and there's no reason to add, there's no reason to divide. Okay? I have a paper which is very close to my heart, and I will end with this, where what we do is we look at the emissions, trying to relate them to the economic activity and other characteristics of the country. How big you are, that matters, right? How many people you have. I mean, you're not going to kill half your population so that emissions will go down. That's not the point. So some of these emissions are factors of things which are not expressed in any of these tables, not even after you divide, not after divisions. And this is one of the areas where you are going to have a natural advantage when you go out there. Because, as I mentioned at the beginning, these things matter. $30 trillion of assets say that this matters. And most people don't know about this. People who know finance, mathematical finance, and this and that, don't know this. I believe MMF is the first program perhaps to introduce these types of situations. So that gives you an advantage, and you should be aware of that. Similar to those few people that in the 80s knew how to do option pricing. As you know, option pricing doesn't give you an advantage anymore. Everybody knows it. But in the 80s, it made a tremendous difference. So something similar is happening here, okay? And my objective for this course is to give you that advantage that you can have, so that when the financial industry deals with the consequences of all of the things that we're talking about, then you are at an advantageous position to take advantage of them. Okay? Okay, I will end it here for today. Next time, I will continue. My objective next day, I mean, I'll spend 2 hours, but my objective is I will show you a carbon trade, which should be the analog of someone showing the first derivative in the 80s. Okay, I'll show you a carbon trade in great detail, and I hope we'll learn very much from it. But that's for next week. Today, I'll end it here.